All right, calculus. Welcome to the second video for areas. The second to last thing we're going to learn this whole year. Again, so section 6.1, areas between curves. I want to find the area of the region enclosed by the given curves. So area is the integral from a to b, y top minus y bottom dx. Again, here's what we're trying to do. So we got these two curves, right? We got y equals f of x, which is this one right here. It's a line. We got that sweet parabola, y equals g of x, right below it. And they intersect at a and b. So we want to find the area enclosed by these two curves with bounds, lower bound a, upper bound b. Notice how y equals f of x would be y top from a to b. It's always above y equals g of x. All right, so that's the whole goal. Okay, so we integrate from a to b, y top, which is f of x, minus y bottom, which is g of x. All right, so we would have no idea how to, we could estimate the area, all right, beforehand, but integration gives me the exact area. That's why calculus is so sweet. So here's your first example. Example 1. So all of them are find the area of the region enclosed by the given curves. All right, so example 1 says y equals x squared minus 2x. That's first curve. The second curve is y equals x plus 4. That's all you're given. I don't give you any bounds. I don't say integrate from -2 to 3 or anything like that. Nope. If no bounds are given, then we have to find out where they intersect. We could graph it like I did there, or we could just do a little bit of algebra. If I want to find where those two curves intersect, I'm going to set x squared minus 2x equal 2x plus 4. Move everything over. Factor. I find that they intersect at x equals -1 and x equals 4. So I know for a fact my integral is going to be from -1 to 4, y top minus y bottom, dx. I just got to figure out which of those equations is y top, which one is y bottom. Which one of those is, so just like before, I have a line and I have a parabola. Now I don't know if that's the exact order, but which one of these is top, which one is y bottom. So in order to figure that out, I know they intersect at -1 and 4. I need to pick an x value between -1 and 4, and I need to plug it in. If I plug it in both, I can find the y value. Whatever has the biggest y value. See, it doesn't matter on this curve if I pick, call that x is 3. If I pick x equals 4 or x equals 6, it doesn't matter which of those x values I pick. Y equals f of x will always have a bigger y value than y equals g of x. So I can pick any one, and I won't pick -1 or 4 because just like here at -1 and 4, I know this is different here, they would tie. That's where they intersect. So I have to pick a x value between -1 and 4. How about 0? I plug 0 into this first equation. I plug 0 into this second equation, as I've done right here. My first equation, I get 0, and my second equation, I get 4. I get 0, I get 4. 4 is bigger. This is y top. This is y bottom. That simple check. Y equals x plus 4 is y top. Y equals x squared minus 2x is y bottom. So there it is. The integral from -1 to 4. This is y top minus y bottom. Subtract all of it. All of it is in that parenthesis. And clean it up. There we go. Now I take the antiderivative. 1 power up divided by the new power. Again, I'm integrating from -1 to 4. Those are my bounds. So I plug 4 into the antiderivative first, minus. Then I plug -1 into the antiderivative. There's when I plug in 4. There's when I plug in -1. You can pause this whenever you need to. I will eventually send you photos of these notes as well. All right, that's what I get when I plug in 4. Do a little arithmetic. That's what I get when I plug in -1. You guys have calculators. I'm just doing off to the side. Gotta keep the brain going. Anyway, I get, how about a fraction? that eventually. My area is just under 21. All right. There we go. That's the first one of a few we're going to do in this video. It's going to take a lot of practice, and I got a lot that we can practice, just like with integration by parts. Use substitution. Use substitution. Integration by substitution. Don't know if we're going to get to integration by parts if we're on homeschool for the rest of the year. All right, so your first curve is y equals 12 minus x squared. Second curve is y equals x squared minus 6. So I got two different parabolas. I got one that's making the U and one that's making the igloo. Can probably guess which one would be y top if one makes an igloo and one makes a U. Anyway, I'm giving no bounds again, so I set 12 minus x squared equal to x squared minus 6. And I get plus or minus 3. So they intersect at x equals negative 3. They intersect at x equals 3. So I know my integral is going to be this. From negative 3 to 3, y top minus y bottom dx. All right. So from negative 3 to 3, those are my bounds. So I'm going to pick an x value that fits nicely in there. How about 0 again? I'm going to plug 0 in here, 0 in there. When I plug 0 in here, I get 12. When I plug 0 in there, I get negative 6. Kind of makes sense. That's the parabola that makes the igloo is going to be above the one that makes the U. That's a terrible drawing, but it kind of makes sense that this is going to be y top. That's going to be y bottom. Again, plug 0 in. I get 12. It's definitely bigger than negative 6. This is y top. Y top is the 12 minus x squared minus y bottom is the x squared minus 6. Clean that up. 18 minus 2x squared. 1 power up divided by the new power. Plug in 3 to my antiderivative minus, plug in negative 3 to my antiderivative. There's big F of 3 minus big F of negative 3. Clean that up. And I get area of 72. Nice 72. Interesting. All right, how about one with trig? Again, no bounds again. I got two different cosine curves. Y equals cosine x. Y equals 2 minus cosine x. All right. Now this is cyclical, so they, one could be top, then one could be bottom, but we're going to find where they on the unit circle, so starting at, x equals 0, or, you could get anywhere on the unit circle, we're going to get those unit circle values there for where they intersect. Okay, you'll see here in a second. Set them equal to each other. Cosine x equals 2 minus cosine x. With the cosine x over, you get cosine x equals 1. Cosine x equals 1 when x is 0 and 2 pi. So back again to the unit circle. And again, 4 pi, then 6 pi, then 8 pi. It is periodic like that. But we're going to do 0 and 2 pi. So the area, 0 to 2 pi, y top minus y bottom. Again, to figure out which one is y top, which one's y bottom, pick an x value that is between 0 and 2 pi. How about pi? Plug pi in there, plug pi in there. Y equals cosine of pi, that's negative 1. Y equals 2 minus cosine pi. 2 minus a negative 1 is 3. All right, that's y top. That's y bottom, because 3 bigger than negative 1. It's y top, it's written first, minus y bottom. All right, negative cosine x minus cosine x. 1 power up divided by the new power on 2. What is the antiderivative of negative 2 cosine x? It would be negative 2 sine x. I'm going to plug in 2 pi to my antiderivative, plug in 0 to my antiderivative. All right, sine of 2 pi and sine of 0 are both 0. It's going to be 4 pi there. Everything here is going to be 0. And my area is 4 pi. All right. That one's pretty nice. Again, I'm giving you all y top minus y bottom examples. Next video, we'll talk about the other scenario. All right, so I've got two more here. Both involve trig, your favorite. So y equals secant squared x. Y equals 8 cosine x. And I do give you bounds. Negative pi thirds, 2 pi thirds. All right, I have given you bounds on that one. So I know the area. Negative pi thirds, y top minus y bottom. Why don't I let x equals 0, something right in the middle. Plug 0 in here. Now remember, secant is the reciprocal of cosine. So secant of 0 is 1 over cosine 0. Well, cosine of 0 is 1. 1 over 1 is 1. 1 squared, 1. 8 cosine 0. Cosine 0 is 1. 1 times 8, 8. This is y top. Cosine x, 8 cosine x is y top minus y bottom, secant squared x. Antiderivative of 8 cosine x would be 8 sine x minus secant squared x is the antiderivative of tangent. Derivative of tangent is secant squared. All right, I'm going to plug pi thirds in for x minus, that's pi thirds in, minus, going to plug negative pi thirds in for x. Sine of pi thirds, folks, that's root 3 over 2. Tangent of pi thirds, this would be something, if you take more math classes, you have to know top of your head, folks, all right? Tangent is sine over cosine. No decimals, no decimals. There's we want to get rid of that, folks. This has an exact answer, all right? Sine of pi thirds is root 3 over 2. Cosine pi thirds is 1/2. So tangent of pi thirds would be root 3. Minus sine of negative pi thirds, that would be 5 pi thirds, which is a negative root 3 over 2. Minus tangent of negative pi thirds is just going to be the opposite of tangent of pi thirds. It's going to be a minus root 3. Anyway, the going to have 3 root 3 minus a negative 3 root 3. Get 6 root 3. All right, just y top minus y bottom. The arithmetic might be a little confusing, but that is it. Y top minus y bottom. Last one for today, y equals cosine x, y equals 1 minus cosine x. Very similar to number 3. You are not given bounds, so set them equal to each other. You get cosine equals 1/2 on the unit circle. Where does cosine equal 1/2? Pi thirds, then again at 5 pi thirds. Lower bound pi thirds, upper bound of 5 pi thirds. Y top minus y bottom. What's in between pi thirds and 5 pi thirds? How about pi? Plug pi in there. Plug pi in there. Cosine pi is a negative 1. 1 minus cosine pi would be 1 minus a negative 1, which is 2. So that's y top. This one right here, 1 minus cosine x is y top. Y bottom is cosine x. All right. There we go. Antiderivative of 1 is x. Antiderivative of a negative 2 cosine x is a negative 2 sine x. Lower bound pi thirds, upper bound 5 pi thirds. So I plug 5 pi thirds in there and there. Minus. Plug in pi thirds in there and there. Sine of 5 pi thirds is a negative root 3 over 2. Sine of pi thirds is a positive root 3 over 2. Now I ran a room, so 5 pi thirds minus pi thirds, that's 4 pi thirds. Then here you're going to have a positive 2. I'm sorry, those negative times the negative is positive. 2 over 2 would cancel. It's going to be a positive root 3. Negative times a negative, that's going to cancel. 2's would cancel. You get another positive root 3. That's why you get 2 root 3 there. All right, this is video number 2 for area. Okay, so jot these down. We are going to have to learn area. I know learning calculus is hard while we're not together, but that's the task at hand, folks. We will make it happen. Zach Math Video signing out.